Hello, welcome to Multimeter 101. My name is Ethan and I'm a support technician. We're going to cover the multimeter basics. To start off with Multimeter 101, we're going to go over the layout and setup of a multimeter. Now with multimeters, they can change depending on branding, so it's important to know and understand the user manual that goes along with that multimeter and brand. So first, we're going to go over these symbols and their meaning. The first symbol we have here is AC voltage. Second one, DC voltage. Third one here is AC voltage, DC coupled. We have ohms here, continuity. We have diode test, farads, and now we're moving into our amperage here. So this is AC with DC coupled, and this is DC by itself. Down here we have our ports. It's important to note these signs. For most Trimble applications, we're going to be using this port here. This port here is to check amperage. So typically we have our black in the common and our red on this one. A quick tip before starting any troubleshooting is to ensure that your test leads on your multimeter are in good working condition. So to do that, what we'll do is we'll take our dial, we'll go over to continuity, and we'll put our leads together. We have a beep, and it reads 0, meaning that we have free flow of electrons through these leads. Now that we've covered the basics, we're going to go over what we typically use to troubleshoot a Trimble system. Typically, we're working with DC voltage, ohms, and continuity. Other than that, you don't really mess with any of these other functions. So setup stays the same here and here. The first function we're going to go over is continuity, which is the easiest. Essentially, you're checking to make sure a line or wire has not broken and is still intact. So to start, we'll do a very simple display of that. So here we took out our fuse, and now we have an open port there where we can stick a test lead. So it doesn't matter which one it is for continuity. Stick it in, put your second lead on there, and you'll hear the beep. Now you can see the value is 0, but now we know that we have continuity. Our line is not broken, and we're good to go. The second function we're going to go over is using DC volts to check power. So right here I have a 12-volt battery set up, connected to this harness here. The same harness we use to check continuity. So when checking power, it's important to put your lead on the same color wire. So red and red, and black and black. So now we see that number on the fluke, it's 1.6 volts. It's not 12 volts, so we can tell that this battery has been drained and not recharged. But other than that, it's pretty simple checking power using DC volts. The third function we use here at Trimble is resistance, which is measured in ohms. I have two terminators here, and we'll check their resistance real quick. So here's our first terminator. When checking resistance, it doesn't necessarily matter which lead you use on which side. It doesn't matter. So here we can tell that this terminator is reading at 119.6, which is in the ballpark of 120, which is typically what we look for. So now, when we plug in this other terminator, we'll see that switch. So now it's at 59.9, which is our optimal resistance reading. That is what we're looking for when we're checking systems.